Here in this video, we are solving a problem basing on transmission of heat, that is thermal radiation, heat radiation. The problem is like this. There are two bodies having same dimensions, that means their areas of cross sections are same. Bodies are also say as though nothing given for you, you shall assume that they are made up of same material, therefore their uh, what is this emissivities are equal. Or you can assume that both bodies are, as nothing is given for you, no emissivity is mentioned, perfectly black bodies, so that their emissivities are equal to 1, both are same, right? And if you notice, nothing mentioned about surroundings. When the heat emission radiation is happening, they will emit heat until surroundings are having temperature less than that of the body. As there is no mention of surroundings, we can assume temperature of the surroundings equal to 0 Kelvin. They are the basic assumptions that we need to make before we solve the problem. We have no choice. Now we can say, according to Stephen's law, energy emitted by a body per unit surface area per unit time is sigma emissivity, temperature of the body power 4 minus temperature of the surroundings power 4. Then we can say energy emitted per unit surface area per unit time is directly proportional to temperature of the body power 4, as nothing is mentioned about surroundings. So E1 by E2 equal to temperature 1 by temperature 2 power of 4. But be careful that this temperature has to be in Kelvin. But given values are in centigrade. So we shall convert them into Kelvin. Whole power of 4. Now you want to calculate by how much percentage energy emitted by second body is more than the first body. We'll come there anyway. 273 plus 27 is 300. 373 plus 27, 273 is 600. Whole power of 4. 3 by 6 power of 4, that is 1 by 2 power of 4, that is 1 by 16. So what you got is E1 by E2 is 1 by 16, or E2 is 16 times of E1. That is, energy emitted by the second body is 16 times of that the first body. And how much more it is, means I have to say E2 minus E1. 16 E1 minus E1, that is 15 E1. So if you want to calculate what is the fractional change in the emission, E2 minus E1 by E1 is 15. And if you want to find out what is the percentage of fractional change, that is percentage of E2 minus E1 delta E by original E of the first body is, whenever you want to convert anything into percent, you should multiply with 100. That is 1500%, which tells you that when compared with the first body, second body emits 1500% of more energy than the first body. This is all based on a law called Stephen's law. Here assumptions are made like two bodies are perfectly emissive bodies, perfect black bodies whose emissivity is 1, and surroundings have 0 Kelvin temperature, as no information is given in the problem about that. Thank you for watching.